So, today we will see in this lecture about the different coastal erosion protection measures. In general, you have sea walls, bulkheads, revetments, groins, jetties, offshore breakwaters. When you look at some of these structures, for example, sea walls, bulkheads or revetments or even groins and breakwaters, the type of material you use is almost the same, like dumping of rocks, and there is a specific way of designing the structure, and the formula which you may be using may also be same, but why are they having different names? The names they derive is because of their different functional, because of its functional aspects, based on its functional aspects, which we will see later. So, now let us consider one by one these structures and try to understand what they mean for us. Sea walls, these structures are massive and quite expensive, should be considered only where the adjoining shoreline is highly developed and storm attack is severe. These are all the general considerations. Seawall protection is for all practical purposes an irreversible act, because the beach in front of it is removed. The fourth point is the seawall will eventually have to be rehabilitated in constant intervals with bigger size of stones if required. So, first of all, sea walls, if there is an erosion taking place, this is the plan and this is the beach profile. So, you have the, this is how you represent in section and this is how you represent in plan the wave. So, these are constructed along the shoreline, and in case this has eroded, what do? You protect it with the stones. First you initially have smaller size stones. Now these days we have what is called as geotextiles, which can run through and anchored properly, and then over which we can have the filter layer, and then we have the bigger stones, and we also can think of having a berm. This is the berm. I will come to that later, but make sure that you have a strong toe protection. This aspect also will be discussed later. So, it depends on the length of the course which is going to be affected. So, if it is like this, there is no point in just considering only this location. You also have to consider slightly on the either side of the affected area. We will also see what happens at the terminal point of the sea wall when after the construction, what happens to the, what happens because of the terminal effects. Sea walls should be considered only where the adjoining shoreline is also highly developed and storm attack is quite severe. For example, here you may have a industry which needs to be protected, okay, and similarly you may have some village to be protected. So it may be a long coastline. This applies in general for all cases, even when you are planning other coastal protection measures, because you should not think of only the local problem. Locally there may be some kind of an erosion, a patch of erosion, but you have to, while designing the coastal protection measure, you have to look at the adjoining areas, so that whenever you try to implement some protection measure, the adjoining shoreline might have some problems. Okay. Seawall protection is for all practical purpose an irreversible act, because the beach in front of it is removed. What does that mean? Suppose this stretch of the coast, for example, this stretch of the coast is lost for over a long distance, and this has significantly penetrated into the land, and you want to protect this area, and assume that you have lost something like 300-400 meters, and protecting and also getting back up to the original location or original shoreline, reaching the original shoreline would not be possible at all. What you decide is, you decide that this is the area which needs to be protected, so you protect it with the seawall. That is, the moment you have protected with this stretch of the coast, that is, this becomes your boundary and not this. That is, the stretch of the land which has already been lost is lost forever. That is, you do not try to play offense with the waves, you play defense. So you limit your stretch of the coast shoreline, you only assume that this is what you can protect, and this is the area which you have to forget about it, which is lost forever. And the idea is that you make sure that you do not lose further. Okay. So it is something like you put a fence, but you mean to say, by doing this, can you really protect the beach, shoreline? Yes, you can protect the shoreline, provided the structure is designed properly and you do not really anticipate severe coastal hazards like severe cyclones, etc. If you have such a sudden outburst of coastal floods, then you are in for problem. And when such a situation occurs, what are we supposed to do? We are supposed to immediately rehabilitate the seawall. For example, when you have a very severe coastal hazard, wherein what would happen, all these stones would be removed and these stones would likely to go here. So this stretch of the coast during one coastal hazard has eroded, for example, and you do not rehabilitate. When you do not rehabilitate, the cumulative effect on the sea wall will continue to act, and you are likely to initially get back to your original situation, and still if you do not respond to the call of the waves, then you can have much more than what had taken place. So, it is extremely important that you have a continuous monitoring of the sea wall once it is constructed, and then keep rehabilitating at regular intervals. When you talk about rehabilitation, it will most likely it will be falling under the category of identifying bigger size of stones, because if you are going to have smaller size stones, naturally it is going to be removed without any problem. So, you have to have all these things in mind when you are talking about the sea walls. The sea walls, as I said, are constructed parallel to the shoreline or along the shoreline. And now you have another word, or this is called as bulkheads. Both bulkheads and sea walls are constructed parallel to the shoreline. They separate the land and water. Here water means I am talking about the sea water, but they get their they get their names only because of the primary purpose for which they are considered. For example, that is sea walls, its main purpose is to protect the rear side of the beach against storm attack. So, again, so this side of the area is getting eroded, so you put the sea wall. So, when you put a sea wall, its main purpose is to resist the action of the waves, so that not more energy contained in the waves is acting on the shoreline, and if such a situation prevails, then the sand will be removed. So, the primary purpose of a sea wall is to protect the land from severe action of the ocean waves. What is the purpose of a bulkhead? The bulkhead, the primary purpose of a bulkhead is to prevent sliding of the land into the ocean. So, when you have some land mass, so you can have a structure like this, which is a bulkhead, which is called as a bulkhead. Now, in this case, the major force acting on this wall would be the earth pressure, because it is retaining the earth, and occasionally there may be some wave action on this wall. Okay. For example, the same thing, if there is not much of wave action and only once in a while, very occasionally you have the action, the waves coming and hitting the structure, then it is called as, it is termed as bulkhead. So, here the major force which is coming on a sea wall is that due to waves, and here in the bulkhead the major force that is coming on the bulkhead is the earth pressure. So, that is why they have two different names. sea wall and bulkheads. In this course I will talk more about sea walls, we will look at some of the case studies etc. Face profile shapes of sea walls. Mostly it was considered that just by dumping the stones you construct a sea wall. That is not the case. There should be a proper scientific method in order to arrive at the cross section of a sea wall. When you look at the front shapes of the sea wall, you can either have vertical, nearly vertical, sloping, convex, concave, re-entrant, then steps. There are varieties of sea wall sections adopted worldwide. Some of these cross sections are adopted for our Indian coast, for example Chennai or Madras or Chennai coast, Kanyakumari coast, that is the tip of Indian peninsula, close to the tip of Indian peninsula, then Kerala coast on the west coast, along with some other few case studies etc. we will just have a look at a later stage. So, we are now seeing one by one the different measures that are available to us for protecting the coast. So, broadly it can be classified as non-absorbing method, as you can see here, non-absorbing method measures or sea walls, and then absorbing type of sea walls. On the non-absorbing type sea walls, you can have all impermeable kinds of walls, and the front face can be vertical as you can see here, or it can have a shape like this, or you can have a shape like this, or you can have a slope. Note that the locations where some of these kinds of walls have been constructed are all incorporated in the slide. And also note that all the pictures show here, which is called as the toe protection, which is very important for taking care of the stability of the structure. What is the purpose and how does the energy get dissipated? Energy is not absorbed because the surface here we are considering is a smooth surface. When we are having a smooth surface, in the first case the energy is lost only by pure reflection. When we have already seen when there is pure reflection, so when you have a wall, I have already told you that the water level itself in front of the sea wall will go up by a certain magnitude, and the wave height, if it is 1 meter, you expect the wave height on the wall to be 2 meters, that is twice the wave height, incident wave height. This is because of the sudden obstruction, and for the wave height to be twice, you need to have the wall vertical and also impermeable. So, when you have the wave height on the wall to be more, naturally the orbital velocities etc. will be more, and so the force exerted by the presence of the structure is going to increase. You are going to have scour problem, you are going to have the forces being increased that would act on the vertical wall. So, vertical wall is not preferred when you talk in terms of coastal protection. For that matter, vertical wall structures should always be are being discouraged, for the simple reason that the reflection is going to be high and the force exerted on the structure is high. But you cannot avoid vertical type of structures in general. There are certain stages where you are forced to have vertical structures, for example berths, open berths, that is in the mid sea you can have open berths, or inside the harbor. Inside the harbor there is not much of problem because the wave heights inside the harbor is expected to be less. There you can afford to have vertical berths. Okay. So, for coastal protection we generally, this is not a good solution, but modification of vertical wall are being thought of. Modifying means what? You have some kind of perforations on the wall etc., so that the energy will get dissipated when the waves are flowing through the walls. I will show you a typical structure later on this aspect. Now, the next one is here, this kind of a convex, or you have this kind of a structure, or you have something like this, all these kinds of shapes, it does not absorb the energy, but the energy is lost by when the waves are running over. When the waves try to run over, it gets, the energy gets deflected back into the ocean, or the energy gets dissipated while it is trying to run over this kind of a shape, or this kind of a shape, or even this kind of a shape. Many times you can, at several locations you have what is called as a crown wall, which you see here, a small projection on top. This crown wall can be maybe thought of when the top level of the structure is already fixed and you have constructed the structure, but then after construction of the structure in a particular location you keep on experiencing continuous overtopping from the waves, or the level as sea level has gone up and you have frequent overtopping of the waves, then you can think of having a crown wall. This can be implemented later, but you have to make sure about the stability of this crown wall after, when it is implemented after the construction of the sea wall. Okay. So, this shows that how these different types of sea walls are considered, and these are all non energy absorbing, because the energy is not being absorbed and the energy is being spent either in the form of reflection or in the form of dissipation. Dissipation in the sense due to run up etc. Under the absorbing type, you use rubble mound as one of the medium for absorbing either the entire portion of entire energy, which is not possible, or maximum part of the energy. So, as you see here, you have a vertical wall, of course, you have you see you can have a crown wall, plus you see the red one, this is the mound. So, when the waves propagate, this mound offers enough resistance to the propagating waves, energy is dissipated because of the permeable medium, and less energy is going to attack, or this wall is going to experience lesser wave force. Or you can have a something like this complete rubble mound, which is quite common, or you can have some kind of structure wherein you can have the stones or the rubble medium, rubble mound being enclosed inside to form something like a caisson. So, it is kind of a gravity structure, it will stand there, but at the same time energy will be dissipated because of this rubble mound. You can also have a combination of this, you have the slope plus you have the rubble mound. The idea is to dissipate the energy due to the presence of the rubble mound, as well as the slope of the wall, the top I mean the sea wall is also going to have its own effect in reducing the energy. Then you can have the normal sea walls, as you can see here, wherein all these normal sea walls are usually provided along with a crown wall, and later berm sea walls have come into picture. All these things are used with rubble mound. It can also be an impermeable sea wall. If it is impermeable sea wall, the energy is dissipated because of shoaling, breaking, etc. Okay. It has to be really sloping, the gradual slope. If you have a gradual slope, the energy can be gradual. When you see later how a sea wall breaks, it will break by the commonly known as slip circle, which we will see later. So, adopting thus that, which I will explain later, they have proved that having a berm as shown here has proved to be more stable. So, this is said to be more effective, and in many of the countries, particularly Europe and other parts of the globe, they consider the berm sea walls. But there are some problems, some minor problems. When you construct a sea wall with a berm, you need cranes that are lifting the stones and placing with a longer boom length. So, if you have a for example, if this is a original slope without the berm, and you have a truck which is moving, and it needs a boom length to place the stones, and its boom length can be up to this location. So, you can place the stones, but if you increase, or if you have a berm, then what happens? The boom length has to be more. So, it calls for special kind of cranes. So, these are all site specific. So, if you want to have, and another thing, another problem is that the imprint of the breakwater is wider, because it occupies, you see, instead of occupying this much space, it is so for example I will draw this. So, instead of occupying this much space, it will now occupy this much space. This was the original width, but now you have, because of the berm, you have the increased width. So, these are some of the demerits, but there are merits which are more towards the stability of the seawall. They have claimed from practical experience that bermed type seawalls or bermed breakwaters are more stable. So, you have to decide what kind of whether you need to have a berm, or you may not, you do not want to maintain a berm, you want to go for a conventional breakwater or a seawall, and then make sure that regular monitoring is there, and if there are some stones being dislodged, you keep rehabilitating at regular intervals. So, hence this is based on the importance of the project for which this measure is being implemented. Okay. So, there are a lot of locations, mostly what I have shown here are locations in US and Europe, but there are a variety of other kinds of seawalls which I will touch, which we will see later. So, these are some of the type of seawalls where you have here, this returns the flow back to the ocean. When it returns the flow back to the ocean, you expect the reflection to be less, and also the run up over the structure is less. When the run up over the structure is less, the anticipated overtopping is going to reduce. Okay. Or you can have this kind of a seawall wherein you have a number of steps, and these are going to act as something like friction blocks, where a continuous reduction in the energy is being offered because of its presence and because of its projections. So, these are concrete type of walls, and they are not rubble mount. Of course, this can also be constructed in terms of rubble mount, a bit complicated, but it can be done. And at locations where you do not have large size stones, when you calculate, the stone size can be something like 2 tons, or maybe even a very vulnerable coast, it may be even 3 to 4 tons. And if you do not have a proper quarry, and if the quarry is located at a very large distance to get such huge stones, then you need to go in for what is called as gabions. These gabions are something like a net, and it is so it forms as a cube, and then you put the smaller size stones, but make sure that it is not smaller than the size of the opening, and then you dump and then you tie the whole thing, and then this gabion will act as a single unit. but the material you use for those gabions should be perfect. What do you mean by perfect? Earlier they were using some kind of cables, and these cables used to get rusted, and in due course it used to snap. Once this happens, all the stones will come out, and then this will become pebbles, and all these pebbles can easily be washed away. So now these days we use what is called as geosynthetic ropes, which are used for preparing the gabion and then putting the stones. So I will show you some of the examples later. So this is a conventional rubble mound sea wall which we have already seen. You look at this wall, this is a concrete wall. Now you have a toe protection here. The importance of toe protection will again be discussed later after about 3-4 slides. In the rubble mound sea wall, note that the drainage is also very important, because when there is a monsoon, the water which gets accumulated on the lee side, and if it starts penetrating, what will happen? There can be a settlement of the sea wall and the whole thing can be washed off. That is the reason they use these days a geosynthetic material. So you need to have a drainage in order to drain the water, storm water. So this is another rubble mound sea wall. This is, I think it is somewhere near in Sri Lanka, along the Sri Lankan coast, and you see that the protection has been found to be quite fruitful, and but only thing is they need to do frequent rehabilitation of the regular monitoring is a must. Plantation, this is also very important. All these things I cover under sea wall because it is along the shore. Plantation also, it will also act as a buffer. Later we will see how plantation has played a very significant role in reducing the effect of tsunami onto the land. I said earlier that a vertical sea wall can also be made perforated, and once once you make such kind of perforations, it can still be used. Although we have seen the disadvantage of a vertical wall, there is an advantage of the vertical wall because it occupies very less space. And another important thing is, you will not, it is not an eyesore. When you go along the shoreline and you see rubble mound sea walls all over, it is nothing, there is nothing, no charm in it, all the aesthetic value is lost. So this is a sea wall constructed in Japan, where you look at this berms, they have, this is how it looks inside the ocean, because we will not be seeing, and you look at here, you have a lot of holes here, so that the waves, when they penetrate into the holes, into this rubble medium, and the energy is dissipated. And in plan, if you look, these people have looks as if they are they have a direct access to the ocean. This is what is called as aesthetic way of looking at coastal protection. Of course, this kind of a structure is naturally more expensive than the other kinds of conventional structure. Hence, a coastal protection measure has also a bearing on so many other aspects like tourism. For example, here this coast getting eroded, they have saved the coast, at the same time provided a beautiful place for the tourists and for the locals. So, this shows the use of gabions as we have seen earlier. This is somewhere in South Africa, in somewhere near Cape Town, where you see the gabions and the stepped wall. As I told you earlier, the stepped wall can be impermeable or it can be formed with the gabions. With the gabions it can be more effective because some amount of energy is dissipated because of the porous medium which we are having there. Is that clear? So, this is in the case of rivers bank protection. Gabions are being used widely for bank protections. So, bank protection also are liable for cover or erosion of the banks. So, they use. So, this is again under the sea wall, wherein they have used what is called as geobags, geosynthetic bags. So, these look like cement bags what we get, filled with sand. So, they pump in slurry, the water mixture of sand and water, the water comes out but the sand retains, and then it is placed like this. And look at this, this is somewhere in Germany, island of Sylt. This is one of the usual common picture you see when you look at the geobag protection. So, this again I am using it under the classification of seawall. This basically, so probably the beach would have been here. Now, what is this? This is what is called as a irreversible act. So, the beach which is lost, but now there is a desperate situation to save this. So, because if you do not do this, this vertical cuts can penetrate, and then you see that this becomes, the existence of that building becomes questionable. So, this is in old Mangalore. This is a bit old picture. Now, the scenario may be quite different, but anyway I am using this picture in order to show you that the geobags were also adopted, but has failed miserably. This is somewhere in Ullal where you see the geobags filled, and it did not sustain the severe erosion that took place after the construction of the sea wall with geobags. Okay. As I said earlier, beach loss eventually occurs in the front of a sea wall for a beach experiencing net long term retreat. So, this is the beach width. Now, you construct a sea wall, beach width is so much, and then that beach also can be lost, but then this sea wall acts like a soldier trying to prevent further loss, but it has to be done carefully. because the seawall itself can be lost, as we have seen in the earlier case. All these things are remains of an existing seawall. So, seawall, if you do not do it properly, the entire seawall can again go into the ocean. These are some of the views how you can protect the coast with the plantations. So, this concerning this picture, I will again be covering under the tsunami. So, wherever you have scope for plantation, it is better you go in for plantation, because the roots have a property to act as a protection measure for by preventing the soil erosion, which I will show you in the next class. Okay, with this I will conclude. Okay, today was it all right?